in humanity's eternal quest to discover life beyond Earth. A groundbreaking revelation has transformed everything we thought we knew. Imagine a world not just capable of sustaining life, but possibly even surpassing Earth in its potential. The James Webb Space Telescope, a true beacon of scientific innovation, has uncovered a new planet. And the estimated probability that life exists there? An astonishing 99.7%. This isn't a wild guess. It's a number rooted in rigorous calculations, built upon unprecedented scientific data gathered by the most powerful observational tool ever created by human hands. The planet revealed by James Webb is a place where life may have evolved in ways we've never dared to imagine. Now, planet is K218b, and in this journey, we're going to explore the data, the logic, and the extraordinary evidence behind this breathtaking figure. Could we one day communicate with the living beings on this planet? What might these life forms look like? And most importantly, what does this discovery mean for the future of humankind? Prepare yourself, because what you're about to discover may forever change the way you see your place in the universe. This is not science fiction, this is real, and it's happening right now. K218b is a member of the K218 star system. Where it orbits a red dwarf star of the same name. Located deep within the Leo constellation. K218b is about 120 light years away from Earth. This is a relatively close distance in the universe, offering a significant advantage for astronomers to conduct deeper, more detailed research going beyond the usual limits of observing distant celestial bodies. In terms of size, K218b is truly a remarkable world. With a radius approximately 2.6 times larger than Earth's and a mass 8.6 times greater. It is classified as a super-Earth or a mini Neptune. This impressive size is more than just a number. It carries important clues about the nature of the planet. Such a large mass and radius suggests that K218b is capable of retaining a thick atmosphere. A key factor in determining the potential to support life. This atmosphere does not only act as a protective layer, but also serves as an environment where complex chemical reactions may occur, laying the groundwork for potential biological discoveries. The initial discovery of K218b was made in 2015 by NASA's Kepler Space Telescope. Kepler was a revolutionary mission, specifically designed to search for exoplanets by observing slight dips in a star's brightness as a planet passes in front of it. This method enabled Kepler to identify K2-18b. It confirmed the existence of a planet in the K2-18 system and marked K2-18b as a potential target for more advanced future studies. In 2017, the Spitzer Space Telescope played an important role. Observations from Spitzer help confirm that K2-18b is located in the habitable zone of its host star, K2-18. This was a major step, elevating K2-18b from a mere exoplanetary detection to a highly promising candidate in the search for life. Two years later, in 2019, the Hubble Space Telescope brought a breakthrough discovery. Using advanced spectroscopic capabilities, Hubble made observations during K2-18b's transit across its star. Hubble detected water vapor in the atmosphere of K2-18b. This was the first evidence of a life-supporting compound on this planet. The launch of the James Webb Space Telescope in 2021 opened a new era for astronomy. Especially in exoplanet research. With unprecedented infrared observational power and far superior sensitivity compared to previous telescopes. James Webb was expected to provide deeper insights into the atmospheric composition of distant planets. K2-18b, with promising signs from Hubble and Spitzer, quickly became one of James Webb's priority targets. In 2023, scientists collected and analyzed the detailed atmospheric spectra of K2-18b. Initial curiosity turned into astonishment. In the atmospheric spectrum of exoplanet K218b, scientists have detected a compelling signature of dimethyl sulfide. This is a remarkable organic molecule. What makes this discovery extraordinary is that, on Earth, DMS is predominantly a byproduct of biological activity. Especially from marine phytoplankton. Its presence on a planet 120 light-years away stands as a powerful signal, one that deserves serious consideration. Alongside dimethyl sulfide, researchers found high concentrations of methane and carbon dioxide. The combination of dimethyl sulfide, methane, and carbon dioxide weaves a portrait of possible life, perhaps not Earth-like, but life nonetheless. Such imbalances where compatible compounds coexist longer than they should often point to continuous biological processes working behind the scenes. Like the tale of Goldilocks, K218b may lie in the just right zone for life. Not too hot, not too cold for liquid water to exist, it's a vision far removed from traditional models of life. If life has indeed evolved in the harsh, alien conditions of a Hycean world like K2-18b, could intelligence, a form of life capable of learning, adapting, and influencing its environment, to follow an entirely different evolutionary path than it did on Earth? On Earth, human intelligence has been shaped by our ability to use tools, engage in complex communication, and navigate terrestrial landscapes. But in a planet-wide ocean with pressures hundreds of times higher, no solid ground, and near total darkness, the evolutionary blueprint would look radically different. Traditional, physical technology metalwork construction fire would be impossible. On Earth, we already see glimpses of this, organisms that form symbiotic relationship, or regulate tiny ecosystems to survive. If pushed further, an intelligent species might grow or cultivate microbiomes to perform tasks, an organic form of living technology. However, what stands out most about K2-18b is that it forces us to expand our understanding of where life might emerge. In the past, astrobiology focused almost exclusively on Earth-like rocky planets, where sunlight could sustain life. Now, ocean worlds and thought to be unlikely candidates are moving to the forefront of research. If intelligent life can evolve without land, without fire, then our most fundamental assumptions must be re-examined with care. One crucial factor that gives K2-18b such immense potential is its host star. K2-18b orbits a red dwarf, a star type known for lifespans lasting hundreds of billions of years, far longer than our Sun. This extended timeline offers a far greater evolutionary window. Giving life, if it exists, a generous span to grow from single-celled organisms to complex, intelligent forms. However, red dwarfs come with their own challenges. They are prone to powerful magnetic flares. Capable of stripping the atmospheres of nearby planets. Yet, the thick hydrogen-rich envelope of a Hycean world like K218b may act as a natural shield. Preserving the atmospheric stability needed for biology to flourish. Humans develop technology through fire, metal, and dry land. But on an ocean planet where nothing burns, no dry ground exists, and immense pressure rules, our version of physical technology becomes impossible. That reality demands we imagine entirely different evolutionary paths for intelligent life. Water, with its unique chemical and physical properties, is not just the foundation of life as we know it. It plays a central role in every aspect of biochemistry. Its exceptional ability to dissolve substances makes it the universal solvent. Enabling the transport and reaction of nutrients, in an ocean where sunlight cannot penetrate the depths, photosynthesis, as we understand it, driven by light may not occur or could be limited only to the uppermost layer where light barely reaches. On the Earth, we depend heavily on light and sound, hearing, for communication. But in such deep aquatic environments, light is quickly absorbed, becoming almost useless beyond a certain depth. In contrast, sound travels far more efficiently in water than in air, especially at low frequencies. Thus, if intelligent marine life exists on K2-18b, it may have evolved a sophisticated communication system based on sound waves. Much like how dolphins and whales use sonar and long calls for navigation and messaging. An advanced intelligence could even refine those acoustic signals into a fully structured, meaningful, and intricate language, capable of sharing detailed information and preserving knowledge. As of now, no scientific evidence confirms the existence of life on K2-18b. K218b may not give us the answer right away. But this planet serves as a reminder: if intelligence exists elsewhere in the universe, it may take forms we've never imagined. It could resonate in strange frequencies, glow softly through dark waters, or connect through faint electromagnetic pulses. We don't yet know, but now we have reason to look. Beneath the endless ocean of a distant world, life may be silently watching or quietly waiting to be found. To begin with, K218b possesses three fundamental characteristics that Earth has. Conditions considered essential for the emergence and development of life. First, the presence of water vapor in its atmosphere, initially detected by the Hubble Space Telescope and later refined by the James Webb Space Telescope. This is a strong indication that liquid water may exist on the planet. K218b orbits its host star within the habitable zone. where surface temperatures could allow water to remain in a liquid state. This is a critical factor, ensuring the planet isn't too hot for water to evaporate entirely, nor too cold for it to freeze permanently. K2-18b's considerable size grants it enough gravity to retain a thick atmosphere. A dense atmosphere acts as a thermal blanket, shielding the planet's surface from harsh cosmic radiation and helping regulate surface temperatures. Minimizing drastic differences between day and night. Geological activity such as plate tectonics and volcanism plays a key role in creating and maintaining the carbon cycle. A crucial biogeochemical system that stabilizes climate and supplies essential elements for life. A planet with sustained, stable geological activity can potentially support life-friendly conditions for much longer periods. But here's the standout feature. K2-18b might be a Hycean world. The Hycean concept is a relatively new one in planetary science. Proposed in 2021, if K2-18b is indeed a Hycean world, as current models suggest, then its environment may even be more stable than Earth's. which has undergone dramatic climate shifts. Through ice ages and harsh geological transitions, this kind of long-term stability could be key to the uninterrupted evolution of life. When we compare other candidates, why does K218b stand out? The figure 99.7% likelihood of life is not a speculative claim. It stems from complex statistical modeling using Bayesian algorithms. A method that quantifies probabilities based on current evidence. Continuously updated as new data becomes available. Together, these factors form the highest probability model ever recorded for a potentially habitable exoplanet. Still, rigorous science always leaves room for uncertainty. And that is why the figure is never 100%, even with a probability of 99.7%. A 0.3% uncertainty remains. And this is not due to doubt, but rather the principle of empirical science. Until we observe directly or retrieve a physical sample, all assessments remain statistical inference. There may still exist an undiscovered geological or chemical process capable of producing dimethyl sulfide without life. And more importantly, the Fermi paradox. If intelligent life exists elsewhere, why haven't we seen them? Yet, in the fields of astronomy and astrobiology, a 99.7% probability is monumental. It's not just a number, it's a guiding light for technological investment. It's the reason why agencies like NASA, ESA, and CSA continue to monitor and investigate K2-18b as one of their top priority targets. The discovery of K2-18b and its potential biosignatures is not just a scientific milestone. It carries immense meaning, reshaping our vision of life beyond Earth and humanity's place in the cosmos. This marks a critical leap, moving us beyond hypotheses and into the realm of observable evidence. If K2-18b truly harbors life, it will profoundly impact how we approach future missions in the search for life. K218b, with its compelling signs of potential biosignatures. Stands as a historic marker in the quest for extraterrestrial life. Still, the journey is far from over. What we see on K218b are only initial clues. Clues that need to be confirmed and studied in depth. Science is a continuous process of questioning. Data collection and building hypotheses. That's why we must continue to follow scientific discoveries, support space research missions, and nurture our curiosity about the vast universe. The cosmos holds countless mysteries yet to be uncovered. K218b is only the beginning. And with every new discovery, we take one step closer to unveiling the universe's greatest secrets.